Hello students, I hope all you are fine and your study well going on. Very good. Let's start chapter motion in physics, and today topic is instantaneous speed, velocity, types of velocity and its examples. So let's start. See this picture here the three living beings which performing motion. In first picture, a snail covers 100 meter in 50 hours, while in second picture, tortoise covers 100 meter distance in 15 minutes, and in third picture, the sprinters covers 100 meter distance in 9.83 seconds. What you observe from this picture? This picture says that different organisms or different objects can cover distances at different rates. It means they have time. They have take time. The amount will be different. Okay, same distance cover in different interval of times. Okay, what do you mean by so this is the speed of different organism. Suppose that speed of sprinters, if they run many times, sometimes they have runs more faster, sometimes they runs very slowly. In this case, we have take just average speed, and average speed is the ratio of total time total distance covered to the total time taken to complete that journey. There is a very important point that whenever any object doing motion and its motion at a particular point or we can say the motion of an object at a particular time or particular instant is known as instantaneous speed of that object. Suppose that any object performing motion in x direction and suppose that at time t the object covers distance x. At time t the object covers distance x meter. So in this case, the instantaneous velocity can be given as v instant equal to dx upon dt, where dx is the small time interval. It is very small, the part of a distance that is very small, and divided by the time interval, which is also very small time interval. So in this case, time instantaneous speed equal to dx upon dt. So in this way, you have completed the topic speed and its different parameters. Okay, now look at the another quantity which is known as velocity. Okay, as we have studied about the speed is done by the object in any direction. There is only magnitude. That's why it is known as a scalar quantity. But in case if there are direction in given, it means there are two things. The object have magnitude as well as direction. So in this case, this is the case of a vector quantities, and vector quantities are those quantities which have magnitude and direction. So that's why this is quantity known as the velocity. It means when any object performing motion in a particular direction, then this is known as velocity of that object. Here the in place of distance we write displacement, because displacement contains direction. That's why velocity can be defined as distance traveled per unit time in a particular direction. This is known as the velocity, and sometimes it is also known as speed with speed with direction. Okay, what will be the formula of velocity? Formula velocity will be velocity equal to the total distance covered by the object in a particular direction. It means its displacement of the object with dividing by the total time taken. It means how much time taken by the object to complete its journey in a particular direction. So it is given as v equal to s upon t, where s is the displacement between 2 points and time taken is t second. So draw this picture in your notebook and write this formula. Just like a velocity, just like a speed, there is a similar units of velocity. You can see here SI units of speed, SI units of velocity is meter per second, or you can represent like that, meter per second. Okay, as you know, it has both magnitude and direction, so it is vector quantity. Now types of velocity, there are two types. First one is a uniform velocity and second one is a non-uniform velocity. Okay, I giving you some examples. Whenever you runs in a particular direction, what you think that you always runs at a constant rate? No, actually your rate of motion changes with the time. Actually your velocity is change continuously, and sometimes if any object cannot change its velocity with the time, then and he is performing motion in a straight line, in case of that there is no variation. So when there is no variation, then this is known as uniform velocity. It means if there is any object performing motion in a particular direction or in a straight line, so in this. Now look uniform velocity. What do you mean by uniform velocity? When the body moving in a straight line covering equal distance in equal intervals of time, this is known as uniform velocity. For example, train travels over a straight line horizontal track. Okay, it change its speed. It covers distances in equal interval of time. Now look at the example number 2, non-uniform speed. What do you mean by non-uniform velocity? What do you mean by non-uniform velocity? Non-uniform velocity are those where the object covers unequal distances in equal interval of time. It means it change its velocity at a different rate. In this case the velocity can be changed. As we know that velocity has both magnitude and direction. If we change the direction of the moving object, then this can change lead to the change in velocity. And if we change the magnitude of the object, it means we change the speed of the object, then this is also goes change in the velocity. So in this two way we can change the velocity of the object. Okay, now look at this picture. Here a object moving on a circular path. This is the circular path or road, and object is moving in this way. What you observe that there is a variation in a direction. Actually firstly object like moves such that, after that this, after that this, like after that such type. Okay, this is the motion of a curved path. This is the motion of on a curved path. So in this case the direction is changed continuously. That's why the velocity changes continuously. So this is the case of non-uniform or variable velocity. Okay, I hope you understand this. The average speed of a moving object can never be zero, but the average velocity of moving body can be zero. As you know that displacement may be positive, negative or zero, but distance never zero. That's why speed is never zero. Okay, next lecture we have studied about the average velocity, and after that acceleration. For the next lecture, we have studied about the acceleration only. Let's see what is the average velocity and where it needed. Actually, what happens when the object continuously change its velocity due to magnitude or direction change. So in these cases we have considered average velocity. What is the average velocity? It can define as, it is the we take the sum of initial velocity and final velocity and divided by 2. It means it is the arithmetic mean of initial and final velocity of the object. So in this case, v average equal to v average equal to u plus v upon 2, where u is the initial velocity and v is the final velocity, and its units are same as of velocity. Okay, note, for uniform velocity, change in velocity is 0. Uniform velocity, there is no change, but in non-uniform case the velocity change in velocity is not 0. वहाँ पर चेंज 0 नहीं होता है, वहाँ पर कुछ भी हो सकता है, मैंने आपको बताया था. And when this change goes continuously, then there is another quantity comes which is known as acceleration. So in next lecture we define and explain what is acceleration and what are the examples of acceleration. So you have find out examples of uniform velocity and non-uniform velocity and write it on your notebook. Thank you very much. I hope you have cleared this.